All right, yesterday we started working with inequalities, and the idea of inequalities, the key idea, solving inequalities, I think should be pretty easy for you to do. It's something you've done in the algebra world, but what's new to you is the interval notation. Okay? Being able to write things in the interval notation. And that was the main practice for you for today, because like I said, I think you should be able to handle the inequalities and being able to solve them. Yeah, I threw a couple conjunction, what your functions are, or questions in there. Ands and ors. Once again, we're dealing with ands, that is an intersection common in both, or is your common in one or both of the sets. Questions, things you need to go through. Solutions, once again, were provided for you, so hopefully you check your solutions and you work towards the solutions. Okie dokie, we're venturing onwards. Today is the last section in chapter 1. We will start dealing with absolute values. And once again, this is something you should have dealt with already. But we're going to go back over it. We'll just go over it a little bit quicker. You get everybody? All right. First two questions up there. Absolute value of 5 and negative 5. Write your values down. What's the absolute value of 5 and negative 5? Jacob, what do you get for both of those?
5.
5. That is correct. Now, when you were in algebra, you're probably given a definition of the absolute value as it is the distance from 0 to a number on a number line. And that was the definition that was given to you. What is the distance from 0 to this number that I have, bless you, on a number line? Well, my distance is 5. When we get to upper level mathematics, we have to start working with a more formal definition of what an absolute value is. Because when you get into calculus and you have to deal with an integral, you have to be able to deal with the absolute value by definition to be able to solve an integral. Okay, so we have to take a look at the formal definition. The formal definition of the absolute value is the absolute value of x is equal to x. It's equal to x when x is greater than or equal to the value 0. When this x value is greater than or equal to 0, greater than or equal to value 0, I just draw my absolute value sign. When this value of x is less than the value 0, the absolute value of x is equal to the opposite of x. So if I take a look, here I have the value of negative 5. It is less than 0. So by definition, this tells me to take the opposite of negative 5, which takes us back to our positive 5. So by definition, our formal definition, we can now be able to evaluate integrals, solve absolute value equations by looking at this definition of absolute value. Well, let's solve an equation. They have the absolute value of x is equal to 5. What values of x would make this work? Okay, Miller?
5 and negative 5.
5 and negative 5. Yeah, I could take the absolute value of 5 or it could be a value of -5. Take the absolute value here, absolute value 5, I check, I get 5, absolute value -5, I still get 5, and that works out. So we can now start to solve equations involving absolute values. Well, let's take a look at absolute value of x plus 1 is equal to 5. Now we can sort of use our noggin here and come up with values, but when we get a little bit more complicated with our equations, we're going to need to find some sort of different method of madness to this. But if I take a look at this, I have absolute value of x plus 1 is equal to 5. Okay, and values that would work, Savannah?
4 and -6.
4 and -6. Bless you. 4 and -6. If I would put 4 in here, I get 4 plus 1, that's 5. Put -6 in here, I have -6 plus 1, that's still the value of 5. Absolute value, that's still a value of 5. We can use our noggin. But let's take a look at this a different way. This value of x plus 1, inside the absolute values, what we said in our previous problem, this value inside this absolute value has to equal 5, or this value inside the absolute value has to equal -5. If this value inside the absolute value equals 5 or -5, okay, I'm good with this because x plus 1 equal to 5. Take the absolute value, you get 5. That's x plus 1 equal -5. Take the absolute value, I still get a value of 5. But what this does is this gives us now 2 equations to solve, which makes life a little bit easier on ourselves. It can equal this, or it can equal this. So now I can subtract 1, subtract 1, subtract 1, subtract 1. X is equal to the value of 4, and x is equal to the value of -6. And that's what Savannah gave us. And once again, you could have probably used your noggin to be able to figure that out. Well, now we have the 2x plus 1 is equal to 5. Absolute value of 2x plus 1 is equal to 5. What would be our 2 values of x that we could put in there to be able to solve that equation? Solve that and check your answers with somebody around you. Brady, what did you come up with?
2 and -3.
2 and -3. Once again, our 2x plus 1 could equal a value of 5, or this 2x plus 1 could equal the value of -5. Okay, so we can subtract our 1, divide by 2. 2x is equal to -6. 2x is equal to 4, divide by 2, we get our value 2 and -3. Once again, we should be able to check this. If I put -3 in here, I got 2 times -3, which is -6, plus 1. That gives me 5. Absolute value of -5 gives me a value of 5. Now let's start turning into inequalities. Well, let's go back to our pattern that we followed up here on top. Our first equation that we dealt with here, is we basically just dropped our absolute values. We just dropped our absolute values and we rewrote. 2x plus 1 equal 5, x plus 1 equal 5. When we did our second equation, we dropped our absolute values, but we made this its opposite, a -5. So we dropped the absolute values, made it -5. Well, let's take a look what happens down here when I have x plus 1, absolute value is greater than the value of 5. Now, we could probably trial and error this and be able to figure out values that would work. But we want to be able to get equations or inequalities that we can solve, because it makes our brain work a little bit better, because we can organize our thoughts in solving equations and inequalities, because that's what we've done throughout our algebraic career. So our first inequality, we could just drop our absolute value signs and rewrite. Life doesn't change. Everything is similar to what we just did up top when we had equality. We now just have our inequality. Well, in our second equation, we dropped our absolute value signs and made this its negative. But we start running into a problem with dropping our absolute value signs and just rewriting this as negative. So just rewriting this as x plus 1 is greater than negative 5 is not going to work for us. So what we have to do is we have to go back into our definition again. And in that definition, what we can do is we can put the opposite of the x plus 1 is greater than this value of 5. So when we have this absolute value, the opposite of the quantity of x plus 1 is greater than the value of 5, we can look to get rid of that negative sign by dividing through by that negative 1. And when we divide through by this negative 1, we have x plus 1, and we have our negative 5 there, which goes with our negative up here. But when we divide through by that negative, what do we have to do with the greater than less than symbol? Flip it. Flips around. So we have to flip this around. So we have the x plus 1 is less than negative 5. Okay, now this is an extra step that you can go through. What we like to do is we just like to remember patterns. Okay, if you remember patterns, this is the exact same thing here. I have the x plus 1 is less than the value of negative 5, but I just have to remember to turn that sign around. Okay, so if you want to write this negative quantity x plus 1 divided by the negative 1, it's always going to flip the sign around to make this a negative. Or we could go from here and to here. You just have to remember to flip the sign around. The last thing we have to worry about is, well, when we had this equality, we had the or in there. We need a conjunction junction. What's your function? Term to go in there then. We need an and or an or to go in there. Question is, what's going to go in there? Well, when we're dealing with this symbol, which is greater than, what we remember, or what I try to instill in people's brains and imprint in people's brains, is when you're dealing with greater, it is or. When you're dealing with less than, it is and. Greater is or, less than is and. Greater is or, less than is and. Greater is or, less than is and. Everybody now. Greater is or, less than is and. Don't hear it yet. Greater is or, less than is and. One more time. Greater is or, less than is and. Come on, Kano, you're going to have to do it now. Greater is or, less than is and. Now, hopefully, it's right in the brain. Hopefully there's an imprint in our brain. So we are greater, so we are or. Now we have two inequalities we can solve. So we have x is subtracting 1 greater than 4, and subtracting 1 here, subtracting 1, x is less than a value negative 6, and we have an or statement in there. So we have x is greater than 4, or x is less than negative 6. So we go to our graph. You only need to worry about the key values here. We have negative 6 and 4. Get your graph down. What would the graph look like for both of those? And then write your solution in an interval notation. Check your answer with somebody around you. Melissa, what your graphs look like? And so then we go to our x is a member of. Okay, x is a member of. We go negative 6 to the left and 4 to the right. So both of our intervals are unbounded. Okay, both of them are unbounded. Going to your positive and negative infinities and beyond. So we have negative 6, or negative infinity to negative 6. We have open on both ends. Union 4 to positive infinity and beyond. And we have 2x plus 1. Absolute value is less than a value of 5. So write your two inequalities down. What would be your two inequalities? Make sure you get your conjunction, junction, what's your function term in there? And this one, what's your two inequalities?
X is
Just your two inequalities you wrote from this.
2x plus 1 is less than or equal to 5, and then negative 2x plus 1 is less than or equal to 5.
So when you multiply 2 by the negative, what would be your inequality then?
Negative 2x minus 4.
Now, you can divide through by that negative sign in there.
2x
Which,
plus
I mean, you're here, you have negative 2x plus 1 is less than or equal to 5. That's fine. That's by definition. You can distribute through the negative sign if you want, or you can just divide both sides by negative 1. Okay, you could do either one. If you want to go negative 2x minus 1 is less than or equal to the value of 5 and solve the inequality that way, that is fine. If you want to go and divide through by the negative 1 and say 2x plus 1 is greater than or equal to negative 5, just need to make sure, turn that sign around. Either one is fine. Okay, the first one here goes back to more of the definition. The second one goes back to more pattern. People, what do you get for solutions on?
x is less than or equal to 2, and x is greater than or equal to
Less than or equal to what? I didn't hear you.
2.
And second one?
X is greater than or equal to negative 2.
Okay, so we have x is less than or equal to 2, and also x is greater than, less than or equal to 2, and x is greater than or equal to negative 3. So getting our solutions down, this goes back to what we did yesterday. When you deal with an and statement, Once again, you're looking for the intersection, so you're looking for the values that are common in both. What are the values that are common in both? Basically, where do you overlap? So the solution of the overlap would be what, Ian?
You want like the member of, or just?
No, just what would be the graph of that?
Between -3 and 2.
Okay, what's going to happen at -3 and 2? Open dots or solid? Close dots, -3 and 2. Then we can go to our interval notation. X is a member of.
Bracket -3, comma, 2 bracket.
So we have brackets on each end to give us those closed intervals. Okay, from -3 to 2. What if we had double absolute value signs? Okay, we still follow our same method of madness. Because we want to deal with our positive side of this. When we deal with the positive side of this, we just drop our absolute value signs. That does not change. Drop your absolute signs and just rewrite. The second, you have to drop the absolute value signs and make one side its opposite. So you need to opposite the other side. It does not matter which side you opposite here. Since we have equality, that is always going to be an or statement. So we have our x plus 3 is equal to the negative of x minus 8. If you made this opposite a negative x plus 3, that would be fine. You just need to make one side its opposite. So it gives us two equations once again to solve. But when we solve the first one, we subtract our x and subtract our x. We're left with 3 is equal to -8. Going to be a true statement? Is that true? No. So this just gives us an empty set. It gives us no solutions. But we can get some solutions out of the second one here. Distribute your negative through. So we have negative x plus 8. So 2x would equal our value 5, so x would equal 5/2. Again, if I would put 2.5 in here, I would get positive 5.5. If I put 2.5 here, I would get negative 5.5. Take the absolute value of both of them, I have equality then. Go ahead and solve the next one. Check your answer with somebody around you. Emberlyn, what do you come up with two solutions?
X equals -4 or 2/3.
-4 2/3, and once again, if you would sub them back in there, you would come down to two solutions that are equal. I have a combo statement. Combo statement, absolute value in the middle. We still follow our same method. The positive side to the absolute value, we just drop the absolute value signs. So we still have 3 is less than or equal to 2x plus 1, which is less than the value of 9. If we make this its opposite, we have 3 is less than and negative 2x plus 1, which is less than 9. You could either distribute through and solve it that way, or you can divide through by that -1 again. If you divide through by that -1, that's going to turn your signs around and make the negatives on the outside. So we have -3 is greater than or equal to 2x plus 1, which is going to be greater than the value of -9. Once again, if you want to distribute this through and solve it, -2x minus 1, you can add your 1 to all sides. You're going to divide by the -2, and when you divide by that -2, it's going to turn those signs around for you. Or you can divide through -1 initially. It does not matter. You have 6 in one, half dozen in another. You have to do what you feel comfortable doing. Me personally, I tend to do my mental math here. I'm going to make this its opposite in my mind. I'm going to divide through the negative, and I'm going to come down to this. Solve both these inequalities. You can subtract your 1, then divide by the 2, or add your 1, divide through by -2. Okay. Solve both inequalities. You'll get 2 combination statements. Get a graph down, and then write in interval notation your solution. And check your answer with somebody around you. Also watch your open and closed dots. Also in your interval notation, We have open dot, closed dot, what goes in our interval notation in regards to your brackets or parentheses.
X is between 1 and 4. X equals 0.
Okay, solutions. Should have separations of 1 and 4, -2, and -5. No, what's going to go at -5? Solid or open dot?
It would be an open dot.
At -2?
A solid.
Okay, we want in between there. 1 is solid or open.
Solid.
And then 4 would be
Open.
open. Once again, it's nice to have the visual down here with respect to our graphs. So when we go to our interval notation, X the member of, I have a parenthesis, or I have an open dot there. So we have an open dot. Next, what's going to go there? Parenthesis, solid dot,
Bracket.
a bracket. So we have our -5 and -2 that we go in between, and then 1 and 4. What's on each one of those, Nick?
Bracket, 1, comma, 4.
Okay, now it can be this or it can be this or this. So that means we have a union between them because it could be this or it could be this solution here. Questions about absolute values? Once again, this is the last topic that we have with chapter 1. We will start going into reviewing of the topics in chapter 1 here. May see an in-class assignment tomorrow with this. With the topics that we've covered. Solutions, once again, are posted on the Classroom. So you should be able to work through your solutions, check your solutions.
Yeah, the go. I studied for it.
And you have a few minutes, the rest of the time is yours. You can start working on it, get some of these done.